What if I told you that right now, as you watch this video, our solar system is experiencing cosmic storms 800 million kilometers wide at its boundary? The edge of our solar neighborhood isn't the calm, empty void we've always imagined. It's a chaotic frontier with weather systems that defy the laws of physics as we understand them. New Horizons, now 8.7 billion kilometers from Earth, has detected plasma temperature variations of 27,000 degrees within distances smaller than the Earth-Moon system. And that's just the beginning of what's wrong with our understanding of the place we call home. For decades, we've pictured the solar system's edge as a relatively smooth, predictable boundary. But the 2026 New Horizons extended mission data reveals something that defies everything we thought we knew. The interstellar medium, the space between stars that should be relatively uniform, appears to have massive density variations up to 300 times greater than expected. It's like expecting a calm ocean and finding tsunami-sized waves frozen in place. If that wasn't strange enough, these cosmic weather patterns show cyclical behavior similar to Earth's seasons, but on timescales of just weeks instead of months, something that should be impossible given the vast distances and energies involved. The magnetic field structures show patterns that one NASA scientist described as physically impossible under our current understanding of heliophysics. Most baffling of all, these cosmic weather systems appear to be organized into distinct fronts and pressure systems that maintain their structure over millions of kilometers, like finding perfectly formed hurricanes in space where no atmosphere exists. How could we have been so wrong about something so fundamental to our cosmic neighborhood? To understand why these discoveries are so mind-bending, we need to understand what we thought we knew about our solar system's boundary. Our sun constantly emits a stream of charged particles called the solar wind, traveling at roughly 400 kilometers per second. This creates a protective bubble around our solar system called the heliosphere. The heliosphere has several distinct regions. First is the termination shock, where the solar wind abruptly slows down. Beyond that is the heliosheath, a turbulent region where the solar wind is compressed and chaotic. Finally, there's the heliopause, the actual boundary between our solar system and interstellar space. We've only had direct measurements of this boundary twice before. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. Their data suggested a relatively predictable boundary, with some expected variations based on the Sun's 11-year activity cycle. Computer models created from this data showed a roughly symmetrical bubble with a slight compression on the leading edge due to our solar system's motion through the galaxy. The interstellar medium itself, the material between star systems, was thought to be relatively uniform, with only minor variations in density and composition. Any weather in this region should be extremely subtle and change very slowly over vast distances and long time periods. This understanding formed the foundation of our models of how stars interact with their galactic environments. It's taught in textbooks and has guided our understanding of not just our solar system, but potentially billions of others throughout the universe. This is where things get strange. In 2024, NASA approved the extended Heliosphere mission, equipping New Horizons with new software to maximize its remaining power for heliosphere studies. The spacecraft began dedicated observations of the outer heliosphere in early 2025. And what it found has completely upended our understanding of cosmic weather at the boundary of our solar system. What I'm about to reveal next is the most shocking part of this scientific mystery, the actual data that's causing astronomers to question everything we thought we knew about cosmic weather systems. If you're fascinated by how the universe continues to surprise us, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these cosmic revelations as they happen. Trust me, what comes next will change how you think about our place in the galaxy. The story of this discovery begins in January 2025, when New Horizons' newly upgraded SWAP instrument, Solar Wind around Pluto, detected the first anomalies. Dr. Elena Rodriguez, lead heliophysicist on the mission, initially thought there was an instrument error. The readings showed plasma densities fluctuating by factors of 20 to 30 within relatively short distances, something that should be impossible in the outer helio sheath. By March 2025, after weeks of verification, the team confirmed the instruments were working correctly. The data was real. The team immediately requested additional observation time from NASA's Deep Space Network to increase data transmission rates. In April 2025, the spacecraft's dust counter registered another anomaly. Interstellar dust concentrations varied dramatically along New Horizons' path, forming what appeared to be dust lanes, with densities up to 80 times higher than surrounding areas. Dr. James Chen at Johns Hopkins Applied Physics Laboratory described it as finding highways in what should be an empty desert. The real breakthrough came in July 2025, when New Horizons detected what scientists are now calling heliospheric cyclones, massive storm-like structures in the boundary region that shouldn't exist according to any current model. These cyclones extend for millions of kilometers and appear to rotate with unexpected regularity, completing a full rotation every 37 days. By September 2025, the mission team had collected enough data to create preliminary 3D models of these structures. What they found left them stunned. The heliopause wasn't just slightly irregular, it contained massive storm systems with features reminiscent of terrestrial weather, fronts, pressure gradients, and even something analogous to precipitation in the form of concentrated plasma droplets. The most dramatic discovery came in January 2026, when New Horizons detected what appears to be a massive, cold front of lower-temperature plasma sweeping through the heliosphere, almost like a weather system moving across Earth. This structure extends at least 7 billion kilometers and shows clear signs of cyclical behavior. With each new transmission, the mystery only deepened. What could possibly cause such dramatic weather-like patterns in what should be a relatively uniform boundary? And what mechanisms could possibly drive weather-like behavior in the near vacuum of space? After months of analysis, scientists have developed three main theories to explain these bizarre findings, each with profound implications for our understanding of the cosmos. The first and currently most supported theory involves previously unknown properties of the local interstellar cloud, the specific region of interstellar space our solar system is currently traveling through. Dr. Sarah Jameson at the European Space Agency explains, "We now believe the local interstellar cloud contains filamentary structures, essentially cosmic, weather systems that create these dramatic variations in density and magnetic field strength. These interstellar filaments appear to be remnants of ancient supernova explosions that occurred millions of years ago in our galactic neighborhood. As our solar system moves through these structures at 23 kilometers per second, they interact with our heliosphere in complex ways, creating the ripples and distortions New Horizons is detecting." To understand this, imagine sailing a boat through water that contains both strong currents and patches of seaweed. The boat's wake, our heliosphere, would be dramatically distorted by these obstacles, creating patterns that would be impossible to predict without knowing the exact distribution of these features. But what makes these structures behave like weather systems with cyclical patterns? This is where the second theory comes in. Dr. Michael Chen at Caltech explains, "We believe these filaments may be oscillating due to galactic magnetic field interactions, essentially vibrating like guitar strings, but on a cosmic scale. These vibrations create the cyclical patterns we're observing. These oscillations would create regions of compression and rarefaction, essentially high and low pressure systems, that move through the interstellar medium in ways remarkably similar to weather patterns on Earth, despite the vastly different physical conditions." The third theory proposes something even more radical, that the interstellar medium itself may contain previously undetected forms of matter or energy that interact with our heliosphere in unexpected ways. Some researchers have suggested these could be related to the mysterious dark matter that makes up roughly 27% of our universe. Dr. Rodriguez points to unusual plasma behavior observed in the helio sheath. "We're seeing plasma structures that self-organize and maintain their coherence over vast distances. This suggests forces at work that aren't accounted for in our current models of plasma physics. What makes this discovery so significant is that it doesn't just change our understanding of our solar system, it potentially changes our understanding of every stellar system. If these cosmic weather patterns are common throughout the galaxy, then the protective bubbles around other stars would be similarly affected, with profound implications for the development of life on any planets they contain. Just when you thought you understood what was happening at the edge of our solar system, the story takes another dramatic turn. In March 2026, astronomers using the James Webb Space Telescope made a discovery that added another layer to this cosmic mystery. While studying nearby star systems, they detected similar weather patterns in the astrospheres of 7 nearby stars, the stellar equivalent of our heliosphere. But here's the twist. These patterns appeared to be synchronized across multiple star systems, spanning over 15 light-years. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains the implications. Finding synchronized patterns across multiple star systems suggests we're dealing with a large-scale structure in the interstellar medium, something that extends far beyond our solar system and affects multiple stars simultaneously. This discovery has led to a fourth, even more radical theory, that these cosmic weather patterns might be evidence of a previously unknown large-scale wave propagating through our galactic neighborhood, possibly a remnant of an ancient hypernova explosion or even the wake of a massive object that passed through our region of the galaxy millions of years ago. Adding to the complexity, the New Horizons team announced in April 2026 that they had detected unusual correlations between these cosmic weather patterns and fluctuations in cosmic ray intensities reaching Earth. These variations show patterns that suggest that cosmic weather at our solar system's edge might actually be affecting Earth's upper atmosphere in subtle but measurable ways. Dr. Elena Rodriguez notes, "We're seeing cosmic ray shadowing effects that correlate with the movement of these heliospheric weather systems. It's as if Earth is experiencing distant rainfall from storms happening billions of kilometers away." Perhaps most intriguingly, some of these patterns appear to correlate with unexplained anomalies in Earth's magnetosphere detected between 2020 to 2025, suggesting a possible connection between cosmic weather and terrestrial magnetic field behavior. The question now isn't just what's causing these cosmic weather patterns, but how they might be influencing our planet and others throughout the galaxy. I genuinely want to know what you think about these incredible discoveries. Which of these theories makes the most sense to you? Do you think we're seeing the effects of interstellar filaments, galactic magnetic field oscillations, exotic matter interactions, or evidence of some larger galactic wave? Or perhaps you have your own theory about what's causing these bizarre weather patterns at the edge of our solar system? Share your thoughts in the comments below. I read them all and I'm fascinated to see what this community thinks about one of the biggest astronomical mysteries of 2026. The implications of these discoveries extend far beyond astronomy. Understanding cosmic weather patterns is crucial for the future of human space exploration. The heliosphere shields our solar system from 70% of incoming galactic cosmic rays, high-energy particles that pose significant radiation hazards to astronauts and electronic equipment. If the heliosphere is experiencing weather-like patterns, with storms and clear periods, this could dramatically change how we plan long-duration missions to Mars and beyond. Future spacecraft might need to time their journeys to avoid cosmic hurricane seasons, or plot courses that avoid high-radiation storm fronts. These findings also impact our search for habitable exoplanets. A planet's habitability isn't just determined by its distance from its star, it's also affected by how well the star's astrosphere protects it from cosmic radiation. If astrospheres commonly experience weather patterns, we may need to revise our criteria for potentially habitable worlds to include those with stable cosmic weather conditions. There are even implications for Earth's climate history. Our solar system completes an orbit through the galaxy every 230 million years, encountering different interstellar environments. If these environments contain weather systems, they might influence Earth's cosmic ray exposure over geological timescales, potentially affecting cloud formation and climate patterns. Some researchers have already begun investigating whether major climate shifts in Earth's history might correlate with our solar system's passage through different cosmic weather regions. Dr. Sarah Jameson notes, "We're seeing tantalizing correlations between certain geological periods and what we can reconstruct of our solar system's galactic journey." By understanding these complex interactions between our star and interstellar space, we're gaining insight into the delicate balance of forces that make our cosmic neighborhood hospitable to life. The good news is that this mystery won't remain unsolved for long. New Horizons will continue collecting data until at least 2028, when its radioisotope power system will no longer generate enough electricity to operate its instruments. Every day brings new data that helps refine our models of cosmic weather patterns. NASA's Interstellar Probe mission, scheduled for launch in 2030, has been specifically designed to investigate these heliosphere anomalies. This ambitious mission will travel 3 times faster than New Horizons, reaching the Heliopause in just 15 years and continuing far beyond to provide direct measurements of the structures causing these cosmic weather patterns. Meanwhile, the Interstellar Mapping and Acceleration Probe, IMAP, launched in 2025, is already providing complementary data from its position near Earth, helping scientists create more comprehensive models of the heliosphere's structure and its response to cosmic weather. With each new mission and observation, we're getting closer to understanding the true nature of cosmic weather and its place in the galactic environment. But cosmic weather isn't the only mysterious phenomenon challenging our understanding of space. In upcoming videos, we'll explore the puzzling, cosmic web structure that connects galaxies across billions of light-years, the unexpected, cold spot in the cosmic microwave background that might indicate a neighboring universe, and the strange, Fermi bubbles, extending above and below our galactic center. Each of these cosmic mysteries holds clues to the larger structure of our universe and our place within it. Subscribe now so you don't miss these cosmic explorations. Thank you for joining me on this journey to the edge of our solar system and beyond. The universe continues to surprise us, reminding us that there's always more to discover, even in our cosmic backyard. Remember, in science, the most exciting phrase isn't "Eureka," but "that's strange." Until next time, keep looking up.